around. Okay, so I'm going to, this is the last slot, so I won't make it too commercial. I'll tell you more about my personal journey in robotics, and make it quick. Okay, so I started pretty early, had access to internet in the very early days, 1982. I started a consulting company in 91, and we basically connected all of Israel to the internet. And we reached like 200 consultants at some point. Then I started a company that was called Exact, and it measured internet traffic and was eventually sold to Amdocs. And after that kind of little exit, I decided to get into robotics, which was always been my secret passion. I knew nothing about it, and I thought it would be super cool to have superhero robots like these Japanese ones from my childhood that saved the world. And so I had some money and time and decided to get married and also build a robotic simulator. So it was called Easy Physics. I think it's still online. It was the first of its kind. It was like taking ODE graphic engine and mixing it with a physics engine, and then creating a robotics thing to simulate and run something called neural networks. Back then there was no NVIDIA or mass scale. And in order to sponsor it, I built an e-commerce company around the theme of robotics, started importing stuff and selling to universities and hobbyists out of England and Europe. I tried to get venture capital. I remember meeting with Excel partners and telling them about a vision of humanoid robots fighting back in 2003, 2004. And they said something like, we don't do time machines, flying cars, and robots. And I think they changed their mind on all three. So RoboSavvy started as an e-commerce platform, so selling just stuff out of my living room, and eventually the living room was too small, so I moved everything into a fulfillment warehouse and started selling. And then from the cash flow, started building a lab and employees, and we built all kind of cool robots, autonomous robots. We worked with National Geographic's tracking animals. We did live shows, stage events. This guy here, the dancing robot, which is also coined as the twerking robot, was the highlight of my career. I've been around with him, I think, for 3-4 years in 50 conferences around the world. The peak was on Fox News. He did his little dance and he fell off the table, and that was seen by Comedy Central, that elected him as the sex robot failure of 2013. So eventually it led to all these robotic inventions led to, we had by then like 7 engineers, embedded electronics, mechanical, software, and we did a project, an industrial project of pulling carts. So this was for a postal, we won a bid for a postal service to replace people pulling carts, the cart operation. And so that became Tugboat, and then I thought, it would be a good time to go back to venture capital. And also I saw all these other companies raising venture capital for robotics. This was in 2015, 16. And so I got some angel money, and then eventually started going into a venture capital route. So basically, so during these 10 years of building different autonomous robots, what I noticed was that everybody was using ROS. It was either that or some monolithic real-time OS. And before ROS, by the way, there was Microsoft, and there were a dozen other published, subscribed frameworks for robotics. And ROS won because of some guy who contributed 30 million to have a university outside of a university, and it was an organization called Willow Garage in Silicon Valley, and they brought PhDs from around the world to do research, but in a kind of semi-organized way, and create source code, open source, that was relatively stable, reliable, and so ROS was born out of that. I visited them back in that period, and it was very interesting to see how they captured the academic world. So they consolidated. Everybody started using it in the academic world, the ROS framework, and then ROS started emerging also after Willow Garage died, disintegrated. Some of the PhDs there formed companies that did AMRs, or autonomous mobile robots, and they used ROS. And there's an interview with Brian, the founder of OSRF, what emerged out of the guys who are running ROS today. And he said he's still surprised that anybody uses ROS commercially. So what I realized is that ROS was a great tool for prototyping, and all these AMR companies are emerging because building an AMR is really easy, and in fact with ROS you do next, and you've got an autonomous vehicle, but then you discover to your dismay that you need 20 engineers in 2 years to put together a fleet of robots and stable and deal with industrial persistency, reliability, and safety standards, and all kind of horror things that didn't exist in the lab. And so I formed a company that would do a commercial ROS. So effectively, the idea is that if you want to build an autonomous logistics, focusing on indoor campus, not highways and Tesla, but the idea is that the software stack would save you 20 engineers. It's a bit like video games. So nobody would think of doing a video game today without using Unity, Unreal, Engine, one of these. Same thing about what we're doing is to say, okay, underneath it's ROS 1, ROS 2, if you know the difference, but then you get a lot of layers that that are very important to actually make a fleet of robots, deal with integrators, deal with safety, deal with unions, with the most horrendous people on the planet that are working in factories and logistics centers. So what do you need for an AMR? You've got you need to do navigation, localization, and it's a very interesting field which is not yet stable. There's many ways to do localization and navigation. Hello, yeah, okay. So there's many ways of doing it. Eventually, probably it will go into ASIC. At the moment, it's still algorithmic, and you can pick and choose how you want to do your sensor fusion. And then there's you need to simulate to be able to simulate in large scales. So from accurate physics simulation in a single robot to mass deployment in the cloud of 100 robots in simulation, and do some statistical analysis and what-if scenarios, and other things like a development framework for engineers, so that you get this kind of game engine environment, and you can code and do your own and make something unique. What we've seen is that there are companies that are offering robotic kind of hardware-software combo, and then there's nothing that differentiates your particular robot. If you're doing a pallet truck, or a floor cleaner, or a flat top robot, there is no real differentiation. Eventually, the Chinese will eat the cake because they're scaling right now, because the Chinese government is sponsoring the robotics. Anybody who implements robots in factories in China pretty much gets a rebate from the government. So I talked to Chinese companies that are selling 15,000 AMRs, and they don't care about the European market, because it just doesn't matter for them. They have a captive market, but eventually that hardware will stabilize and will be the best, and then it will flood the market with hardware. So it's also an opportunity to kind of determine a separation between hardware and software. The hardware will eventually be Chinese, and the software will be competitive. So there's fleet management, and then there's this thing called cybersecurity, which most industrial operators don't know what it is, don't know, because they say there's no internet, there's no problem. And but they use Wi-Fi, and there's all kind of side effects, and I'm just hoping that some horrible disasters will occur soon. And then, just like at the beginning with VRM, at the beginning of the antivirus thing, there's stories about how you bootstrap an industry. So there's all this stack. It's like a huge software stack of stuff that needs to be done. And so that's what we're doing. So the options today is either to develop it in-house or to use ROS and get somewhere, or buy some off-the-shelf hardware, software combo. And the hardware also deals with safety, and that's another thing. Safety regulations are really convoluted. We've identified something like 30 regulations in Europe that are relevant to an autonomous industrial mobile robot. Anything from electrical to very specific things about autonomous navigation indoor with people around. And it was a very tough job to identify what belongs to the Linux side of things and what doesn't, and where to delineate this kind of the safety standards, how they get implemented, and what's the minimum viable safety rated autonomous robot from a hardware, firmware, safety rated hardware. It can get very expensive if you do it naively, and so there are all these considerations. So eventually I raised some money, and we just kind of completed a Series A, 40 employees, and so it started in Portugal. You may ask, why Portugal? I've been out of Israel since I think '98, and my Dutch wife likes Portugal, so we moved to Portugal at some point. And so I was an early adopter. Now all of you have Portuguese passports. I know. You're welcome to come. My wife can help you with real estate. And Portugal has amazing engineers. They used to be cheap before COVID, and so that's why we're in Portugal. Now we have also an office in Israel. We got money. We've got now basically the headquarters is in Israel now. So we've been working with different robots, and we've been already deploying in large organizations like Bentley's Motors and Zalando and Dell, and so we've used this software in deployment with robots in real large organizations. So here, for example, in Bentley's request. Okay, doesn't work. But there's anyway. This is in Bentley's Motors. They are. You would have seen the robot hauling around cows. So they take the whole. I don't know what it's called, a rack. It's a rack with the hide of the cow from one side of the factory to the other, and going with people around and chaos. We had another one where it's a mail operator where the robots are working in combination with a safety cell of a robotic arm and with people around, and so the software allows to combine information which is outside of the robot as well. So the treatment is for the entire the conveyor belts, the safety PLCs, the safety cell, the robot arms. So it's a single software that controls everything and integrates with the back office systems, and it passes the scrutiny of the unions. Okay. All right. So maybe this one. So yeah, this is another robot we're working on, which is a pallet mover. So it's another kind. So there's different kind of common frameworks for moving stuff around. It's called intralogistics. It's a domain. There are huge exhibitions about intralogistics. This is not your typical Silicon Valley stuff. It's a dark side of the world with $100 billion market. which moves stuff around, moving stuff around in factories and in industrial operations. So yeah, that's about it. Thank you.
I have one question.
Yeah.
I mean, why did you decide to build your software on top of ROS? I mean, you said ROS is a problematic, even Brian said himself.
Yeah. So the reason is that the problem of ROS is that, so first of all, the advantages. The advantages is that you've got the ROS canon when you have like the ROS version now is Neotic, whatever. It's a version of 2020. So it's a canon of 1,000 executables, and these executables are anything from drivers to face detection, snake movement, space robots, anything. So you have modules or nodes, executables that can do specific things. The quality of the code varies. So some of them are written by professionals, and some of them are written by students with varying degree of capabilities. So ROS had some bad reputation around because it depends on the quality of the algorithms that you use and how they're implemented. So it's not it's run as an NGO. OSRF employs about 40 people, but the canon of ROS includes 200 contributors. So stuff from 200 contributors, and there's varying degree of reliability. The other thing is ROS 1 was not designed for a fleet, so it wasn't designed really for dealing with multiple robots talking to each other over Wi-Fi. It was more around, I mean, ROS was built around the concept of a robot in a building bringing beer from a fridge, called PR2. I don't know if anyone here remembers. So that was so now they built ROS 2. They basically adopted an industry standard called DDS, which is an alternative to TCP, which provides a lot of functionality that TCP lacks, TCP/IP. So it's over UDP, and it's not done by ROS. It's done by, there's like 7 companies that make the stack, the networking stack that ROS 2 uses. So there's this abstract layer of communication of messages that pass. It's maybe a laser. So if you're a laser LiDAR manufacturer, you say, okay, here's the standard ROS message from a LiDAR, and then you have 100 algorithms that already are in production and can use your LiDAR. That's the advantages of ROS. So the reason why it's not wasn't commercially viable initially, the idea was that it wasn't really meant to scale. It was more meant as a lab environment, but we took out the stuff that wasn't good, and we put new stuff that is good, and you can pick and choose. It's like an app store. So if you like a certain algorithm, you can use it. If not, you can write your own. But by and large, it works, and there's nothing like it. There's nothing out there that has that kind of community and plenty of algorithms to choose from and get you going if you want to build an autonomous robot. Also for robotic arms, if you want, everything from bin picking, path planning, segmentation, all that stuff for visual servoing in robotic arms applications. It exists in open source as well. So it's definitely viable. It's just a prototyping environment. Just like MATLAB, nobody uses it in production, but everybody uses it. Doesn't mean that MATLAB is not good for production, just nobody uses it. Okay.
Bereshit 1, the spacecraft,
What?
was using MATLAB.
No.
Oh yeah? All right. Thank you.
So that's it. Thank you, Limor. It was very interesting. We're using ROS, so we're moving to ROS 2 actually. So it's part of it. So we are very interesting to hear about that. So for everyone here who lasted till the end, thank you so much for coming. There is a time for open mic, so if someone wants to come and say something to the community, it's the time. Someone here wants to say something with the microphone on. You want the microphone?
Maybe I would just say something that if any one of you is like interested in like getting investment, like open to discussing it.
Discussing what? Sorry.
Like investments.
Investment.
Investments.
Okay, you are.
If you need some help or if you need a check.
All right. You are investing.
Yeah.
All right. So what is your name? So people know. Omri. So Omri is over here. I can say that we are a company, not Israel, well, into robotics. We're also hiring an embedded engineer. So if you are looking for a job in robotics, we're doing autonomous drones for indoor locations. So interesting stuff. We're looking for an embedded engineer. Someone else? So again, thank you so much for coming today. It was awesome to see everyone here after such a long time. And thank you for all the speakers. So see you next time.